there anyone not in a team now? Like, if you put the hands up. Yeah. So if you want, at the end, if you want to come up after, and they will group you all up together. Okay? Cool, at the end. So just what is machine learning? So it's a field of study in AI, so concerning development and study of statistical algorithms that can learn from data and generalize with unseen data. But if you want like a simple definition, you'll be teaching computers to learn patterns from data rather than just being explicitly programmed to do so. And under the hood, we have lots of maths there. Some of the use cases, as you know, maybe retail, in finance, healthcare, or many other like industries, maybe entertainment as well. So if you go for the workflow, first of all, it's about understanding the project, what are the goals, why you're making the actual model for. Then we spoke a lot about this before, data preparation, so one of the main ones as well, just about making sure the data is clean and it's fit for purpose for you. Then we have the actual modeling, so actual training of your models and making the predictions, tuning it, and then actually testing it. And then after which we are deploying into the actual world. So classical machine learning we have split in two. So we have the supervised learning and unsupervised learning. So these are the main ones. We have classification, regression, clustering, association, and dimensionality reduction. So for supervised learning, we use labeled data where the model learns from inputs and their corresponding outputs. So for Kaggle competitions, we will mostly be looking at these supervised ones. For unsupervised, it's mostly about learning from unlabeled data and trying to kind of get patterns from it, so try to understand. So if, for example, in market segmentation, that's a really good use case for it. So some common machine learning algorithms, we have like linear regression, logistic regression, decision trees, support vector machines. We'll see these ones a lot. So this is a good example of logistic regression. So here we have the boundary. And on one side of the boundary, it's predicting the true samples, and on the other one's predicting the false samples. So basically making sure, so on one side, let's say if it's a spam or not spam example, so on one side will be the spam ones, predicting spam, and then the other one starts saying not spam. So to actually train a model, we would use these training data, and then out of the training data, we would get a sample of the test data. So to actually train the model, we would use it, and then at the end, we'd only use the testing data. And if you have enough data, we would use also the validation to basically make sure while you're training the data, make sure that it is getting the results that you need and to tune the model appropriately. So for the Kaggle competition, usually they give out your training data and testing data separately. So yeah, so what is the x and y? So x we have the independent variable, and y we have the dependent variable. So you can think about it an example like in predicting house prices. So if you have x as maybe the number of bedrooms, and then based on that, you predict the house price y. Some of the common regression matrix, we have the MAE, so that's the mean absolute error. Then you have the mean squared error, the RMSE, and then the R squared. So these all are like more mathsy if you want, but you can also learn, you can also just do it from Python, has libraries that can do it themselves. So for the classification metrics, we have accuracy, so that's the overall correctness, we have precision, and we have recall, F1 score, and then confusion matrix, which gives you the full picture of the mistakes. So here we have a confusion matrix for the true positive, false negative, false positives, true negatives. So and also the formulas for the accuracy, specificity, and precision recall. So in some cases, you might care more about the specific ones in the confusion matrix. So you might care more about the false negatives. For example, if you're working in healthcare and you want the patient, so for example, false negatives, like if the patient has cancer, but the test says no cancer, and that'll be a big fail from you. That'll be very dangerous because it's easiest missed. So you might care more about the false negatives in that case. And then the false positive is important let's say, important email marked as spam, then you miss an important job offer or like a notification that you want. So in some cases, you might care about one of the boxes more than the other ones, depending on the use case. But there's many algorithms to learn that. So if you just go through some code here, I have so if we go through some code here, so you have data set here, which is trying to predict kind of fake and true tweets, which is kind of a hard kind of program to have because
do you mean
who
like
would
factually true, or do you mean that it's a real genuine tweet from the person? Like, is it a real Elon Musk?
Yeah, I think it's just tweets. So it's actually it's kind of a hard problem to have because who actually determines which ones are fake or true. So it's kind of a hard problem to have. But just as an example, I'm using it today. So doing some basic data stuff, assigning the class one. The class target is 0 and 1, the one that we actually want to predict. We're merging the data sets in my one. It's true data set and fake data set. We're merging them both together. And then removing the columns that we don't need. In this example, there's no null values. Then actually shuffling the data set, because when you're merging it together, it's not shuffled, so you wanted to shuffle it to get the best accuracy from there. This function. So from there, I'm actually splitting the training and test set because in the example that we're working with, there's a specific one for train, a specific one for test. For this one, I gotta actually split it myself and using it by 25%. Then because it's data, I gotta vectorize it and then actually importing the model and then training it and then running the training accuracy and then getting the test accuracy afterwards. So that's a very basic example of kind of training a model, getting the accuracy, getting what you need from that. So that's basically it. Very basic example today.